We'll close this chapter on pointers with an exercise. For this exercise, we're going to build an array of random numbers and sort that array into numeric order. To do that, we're going to have to implement the swap function that we built earlier in the chapter using pointers. And then we're also going to have to create a new function called exchange sort, which will perform the sorting. The exchange sort works by moving through the array, starting at the first element and comparing the first element with the other elements of the array. When comparing two elements, if one element is less than the other one, it is moved towards the front of the array, and the larger element is moved to the back, essentially exchanging places. By the end of the function, then the array will be in sorted order. As I build the function, I'll add some cout statements so we can watch how the exchange sort works in practice. I've already built a couple of the functions we're going to use, the build array and display array functions. Now let's look at the swap function and the exchange sort function. We've already seen how the swap function works. We'll have two pointer variables, each integers, num2. And then right here we'll create a temp variable and assign it num1. Then we'll take num1's value dereferenced and assign it num2's value, and then we'll assign temp to num2. So there's the swap. We've already seen that, so I think you understand how that works. The exchange sort function, and I made another mistake, that's a void function. Let's fix that. Exchange sort works like so. Its arguments will be our array and the size of the array, and then we're going to have a series of nested for loops. The first loop, or the outer loop, will run from 0 through size minus 1 of the array. In other words, the next to last element, incremented by 1 each time. And then in the inner loop, it will start at the I plus 1 position, run until it's less than the size through the last element, incrementing by 1 each time. And then all we do is make a very simple test. If the ith element of the array is greater than the jth element of the array, or the jth element, it's hard to say, of the array, then swap those two elements. So we pass address of operators or references to each of the elements, since that is a function that uses pointers. And that is all we have to do. Now what I'd like to do is, in fact, let me make a modification right now. Let's add a cout statement, or better yet, we'll just do a display array statement right here. So we're going to pass in AAR and size, and that way we can kind of take a look at the function as it's sorting. All right, and that looks like that's all we need. We may find a mistake here. We'll fix it if we do. We'll get rid of this hello world. First we'll create our size of our array. Let's make it 15. Tell you what, let's make it 10. That'll be a little bit easier to keep track of. Then we're going to declare the array. Then we'll build the array with numbers and size. And then we'll call exchange sort with numbers and size. Let's build and run the program. No mistakes. And we left out a cout statement to make our output a little bit easier to read. So move that here. And actually we'll need, yeah, that's fine. And then right here, cout indel. Let's see if that doesn't make it a little bit easier to read. Build and run, there we go. Now you can follow it very closely. So the first time through, we get 3. So I'll tell you what, let's do. Let's do one more thing. Let's call display array before we call exchange sort. In fact, let's put a little heading here, cout before sorting, cout indel. I could have put it on the same line, but that's okay. Then display array, and then exchange sort. And that should give us a better idea of what's going on. So before we sort, here's the array. We probably could use one more cout statement, so let me do that right here. I'm sorry, cout indel statement. Now let's see how it looks. Scroll back up. Before sorting, we have 60, 37, 24, 56, 7, 42, 86, 49, 22, and 10. Notice that the first swap is 37 and 60, and then 24 gets swapped with 60. So notice how the next swap has 7 move in place of 24. So you see how the exchange sort works? 24 is actually less than 60, but because we're just exchanging, it swap places. So watch the 24 as it moves over. And we still have a 22 way over here on the end, so it gets changed eventually. And then we finally end up at the end, 7, 10, 22, 24, 37, 42, 49, 56, 60, and 86, with a sorted array. The exchange sort is not by any means the most efficient of the sorting algorithms. In an advanced C++ course, you would learn much more about shell sort and quick sort, which are two of the fastest sorts. But the exchange sort is one of the easiest to implement. Notice that we only needed, if you discount these 2 lines, we only needed 1, 2, 3, 4 lines to implement the function. So it's a very easy sort to create. It's just not particularly efficient because of the way it exchanges elements in the array. But it gave us a chance to play with pointers, at least in the swap part of the function, and gives us a feel for how pointers are used in C++ programming. Now we're ready to move to a very important topic in C++ programming, and that's the creation of classes and object-oriented programming.